All right, calculus people, we already went over 1A in class, so I won't be going over 1A. And hopefully you guys, after you did 1A, you've taken an opportunity to try 1B on your own. But after you've tried it, then you should come back and watch the video to see if you got it right. So I'm going to go ahead and go through here and work these out for you. So FRQ 1B. A zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon, so T equals 0 is going to represent noon, and 8 p.m., which is going to be T equals 8. The number of entries in the box, T hours after noon, is modeled by the differentiable function E on the interval from 0 to 8. And then they give us various values of E and hundreds of entries at various times in this table here. So at noon, there are no entries. At 2 p.m., there are 400 entries. At 5 p.m., there's 1,300 entries. And at 8, there's 2,300 entries. That's a lot of people that want to name a baby elephant. Okay. All right, so for number 1, we're going to do two things. We're going to evaluate the integral, and then we're going to interpret it. Okay? So first of all, we're going to integrate E prime. Now, when you integrate E prime, you get just E. And then we're going from 0 to 9. And therefore, using the fundamental theorem of calculus, we have E of 9 minus E of 0. And E of 9, I'll have to fix that. That's supposed to be an 8. We don't have any 9s on here. My bad. So it's just supposed to go from 0 to 8, not 0 to 9. All right. So E to 8. E of 8 is going to be 23. E of 0 is going to be 0. And then we end up with 23 as our final evaluated answer. But now we need to interpret it. Just so you guys know, though, that this piece here counts as 1 point, just getting the correct answer for the integral. The next part is the interpretation. Okay, so the interpretation would have to include the units of the input, the units of the output, as well as just basically what the answer means in the context of the problem. And so what this means is since these are E values, this represents an E value, 23. And what that means is that's elephants, right? So we're talking, or hundreds of entries, I mean. So we're talking about the number of entries that were given to name this baby elephant. So now the input units, the numbers that we plugged in, 8 and 0, those numbers are T values, which are in hours. And we're going from T equals 0 to T equals 8. Now, since this was an interval, right? We're going from T equals 0 to T equals 8. The number of entries was 2,300. So here's basically our interpretation. On the time interval of T equals 0, T equals 8, hours, make sure you include those units, the number of entries increased by 2,300 entries. Okay, so and also, as you can see here, I've included the units for the input. I've included the units for the output, and then in general, I'm just interpreting the answer. And I think that this increased here is important because it's telling you went from 0 to 23, and that's a positive 23, so it's increased. If it was negative, that would mean we decreased. Okay. Technically, just to stay safe, you could say the number of entries changed, and that way you're not specifying whether it increased or decreased. But I have seen them grade in such a way where they actually want you to say increase or decrease in this case. So I would encourage you guys to do the same. And so that interpretation with all three of those pieces included, the units in, the units out, and the general interpretation is worth 1 point. So that question on your FRQ will be worth 2 points altogether. All right, go ahead and take a look at number 2. For number 2, this is a U substitution problem. So first thing we're going to do is we're going to identify our U value. My U is going to be t over 2 plus 1. Now it might help you if I rewrite this a little bit when we try to find the integral. If I rewrite it like that, instead of putting t over 2, putting 1/2 of t might be better. So now we're going to do our process here that we usually go through. I'm going to find the derivative of u with respect to t. Now you got to get these variables right? My input unit is t, and it's a u now, so it's du dt. Don't put du dx. So the derivative of u with respect to t, well, the derivative of this first piece is 1/2, and then the derivative of the other one over here, the 1 is just 0. So next, we're going to multiply both sides by dt. And then after that, we're going to multiply both sides by 2. So now I have 2 du, right? So we're ready to do our u substitution at this point. We have e prime of u times du, right? And whenever you do u substitution with definite integrals, you also need to change your limits. And the way that we do that is by plugging in the limits they gave you into your formula for u. So let's plug in the 8 first. 8 over 2 is 4, and 4 plus 1 is 5. So the top limit becomes 5. Next, we're going to do the bottom number, the 2. So I'm going to plug 2 into my u function now. 2 over 2 is 1, and 1 plus 1 is 2. So now we have those new limits. So right there, if you guys were to write that down, you're going to get a point. That demonstrates that you know how to do u substitution with changing limits, okay? The next thing we're going to do is we're going to go ahead, I'm going to take this 2, I'm going to bring it out to the front. So I'll cross it off there. And then we're going to integrate. The integral of e prime is, of course, e. So we end up with the following. The 2 is still in the front. Next, we're going to go ahead and do the fundamental theorem of calculus. So we're going to do 2 e of 5 minus 2 e of 2. And e of 5 is 13. And e of 2 is 4. In this case, simplifying it's not all that hard, so I'm going to go ahead and do that. But technically, you don't have to simplify at this point, because on FRQs, as soon as you get to the basic math, simplifying kind of stuff, it's no longer necessary. So we end up with 18. And on this particular problem, you don't really need to interpret the answer. It doesn't ask us to do that. So that's your second point. So the first point was, did you do the u substitution? The first point was that, and the second point was just getting the right. Right. Let's go ahead and take a look at our last one here on number 3. And once again, same error is on here as on the one that I gave you guys earlier. There's supposed to be a prime right here after that e. All right, so with this one, we have to integrate each piece separately. So I'm going to integrate 6t from 5 to 7. And I'm also going to integrate the 2e prime of 2, or t, I mean, 5 to 7. You just integrate each piece separately. All right. Make a little bit of writing space for myself here. that table up so I can see what I'm doing. Okay. So first of all, if I integrate this, we're just going to integrate that using the power rule. So I'm going to add 1 to the power, and I'm going to divide by that number. And if you integrate e prime, you just get e. Right. And the next thing we're going to do is we're going to go ahead and just plug in our answer here. So 2 goes into 6 3 times, so I'm just going to change that to a 3 right now. So I really just have 3t squared. So it's going to be 3 times 7 squared minus 3 times 5 squared plus 2 times e of 7 minus 2 times e of 5. All right. And we can't stop just yet. We do have to, we can't leave the e of 7 and the e of 5 like that. We have to actually plug in what those are. But once we do that, we can actually stop. I'm not real keen on wasting my energy trying to do 7 squared and multiplying that by 3, although you can. But I'm just going to leave it like this. And you don't even have to do the 7 squared, which I did, because that's just basic math stuff. Not a big deal. You don't need to do it. The thing that really matters is that we need to make sure that we know what e of 7 is. E of 7 is 21. And e of 5 is 13. That's good enough. I'm not going to simplify it. And the more you simplify, the more likely you are to get it wrong. So you might as well just leave it at that point. And so for this one, my guess is that this one could either be worth 1 point because they've already tested your ability to do integration, so they might not give you another point for integrating again, like changing e prime into e whenever you integrate it. It's possible, though, that they might give you a point for the integration. I think on your guys' quiz, I'll probably end up making it 2 points as well, just making sure that you got the integral correct first, and then after that, getting the answer correct. So there's that. All right, now let's go ahead and move on to 2A. Now in class today, we did not get a chance to go over the answers to this one. Now, I did talk about some strategies, though. What I talked about with you guys is how important number 3 is. Number 3 is worth a lot of points, finding a particular solution. So if I were taking an AP test, I would start with number 3. And that's what I'm going to do now as I work with you guys on this one. I will do all of them, don't worry, but I'm just showing you how you want to be strategic as you guys are going through these exams, because you're not always going to have time to do everything that's possible. And so you want to make sure that you're using your time wisely. So number 1 is even though I'm not saying don't do number 1, if you got time, go for it. Now I noticed in class today, a lot of you guys had trouble with that one, but usually those are pretty chill for people. And so I'm not too sure why it was hard, but if it's an easy question, do it. But understand it takes a lot of time and it's only worth 1 point. But number 3 is worth a lot. So we want to do number 3. They want me to find the particular solution. So let's do that. All right. So step 1 is to separate your variables. So if you multiply both sides by dx and then multiply both sides by 4y, you're going to end up with this. Now that alone is worth 1 point. Just doing that, separating the variables, getting the x's on one side and the y's on the other. Okay? The next step is to integrate. If you integrate the left side, you're just going to use a basic power rule. You're going to add 1 to the power, and you're going to divide by that number. And the integral of cosine and sine. And we don't want to forget our plus c. Okay? That's worth 2 points because we integrated 2 different things. Now, sometimes they're easier integrations. Sometimes they're a little bit harder. In this case, by my own estimation, it really wasn't too bad. Now I just simplified it. They're not going to give you a point for simplifying it, though, but I'm going to simplify it just because it makes things a little bit easier. Now step 3. Step 3 is we want to find the c. They did ask for a particular solution. And so that's where we're going to plug in our initial condition to find the c value. So in this case, the x is 0 and the y is 2. So if I were to plug those in really quick and solve, then I'm going to be moving on to getting my next point for this question, which is finding the c value. Let me read something here real quick. Okay, so let's simplify this and solve for c. So 2 squared is 4, and then times 2 is 8, so I end up with 8 equals sine of 0 is 0, and therefore I can see that my c value is 8. Now that's worth another point. If you plug in your initial condition and find c, you just got another point. So now we have this, and we're almost done. All right, the next thing we want to do is get y by itself. There's 2 steps involved here. I'm going to divide both sides by 2. More writing space for myself here. Okay, next we're going to take the square root. Now when you square root both sides, since it's a square root, you got to remember this, easy to forget, we usually get a plus or a minus, a plus and a minus. Now in this case, we are going to pick either the positive or the negative. Now look up here. As you guys can see, that's a positive y value, right? And so I'm going to make a little note here. You don't have to write this when you're doing an FRQ, but I'm going to just do it for your guys' notes, okay? Since given f of 0 equals 2, that means y is positive, right? Because it's 2. Therefore, and that triple dot little thing I just drew, that's usually the symbol for therefore. Therefore, we have y equals the square root of, and then everything we have under the root there, which is sine x plus 8 over 2. Now why is that? Well, because this is what we're finding here is we're basically finding the equation where if you plug 0 in for x, you should get a positive 2. So if you plugged in 0 here for x, that's, and simplified this, you should end up with a positive 2. Now, if I had the negative out here, then my answer would come out to be negative. But it's not, it's positive. Now, if I had changed this problem, if instead I had said that f of 0 equals negative 2, then our final answer would be the one with a negative in front of it. So that's a little trick there you might want to be careful of. Could show up on our test, so be aware of it. Depending on whether the y is positive or negative, that's going to indicate whether you pick the positive or negative to represent your final answer. Okay? And so for this one, that's your final answer there. And getting to that point is the last point. So that's 5 points for doing that entire process. Okay? All right, let's go ahead and move on to another question now. Now, as I'm looking at FRQs, number 4, I just know is a pretty easy question to do. And it's fast and it's an easy point. So I would move on to doing number 4 next. Here's a more detailed image of the slope field of the given differential equation. Sketch the particular solution if f of 0 equals -2. So I'm going to find the point 0, -2, which is down here. And I'm going to sketch the solution. Okay? And that's what we did in class for our last lesson. And it's basically just following your slope field. It's going to look something like this. Okay? And that's what the general solution would look like. And doing that now, I realized I helped one of you groups in class, and I thought this was a positive too. So I sketched the solution up here when I was helping you, but it's negative. Sorry about that. It's actually going to be down here and follow this one. All right, let's go ahead and take a look then at the other ones. So now, let's go ahead and do number 1. Let's sketch the slope field. So how slope fields work is you pick a point. You identify the coordinates for that point. And you plug them into your differential equation. I'm going to plug in pi over 2 for the x. I'm going to plug in 2 for the y. And cosine of pi over 2 is 0. 4 times 2 is 8. And anytime you have a fraction with 0 on the top, you just get 0. And so what that tells me is it tells me that the slope of my function at that point is 0. And 0 slopes look like horizontal lines. So I would just draw a horizontal line right there. Now sometimes you can use little shortcuts to find other answers. Like for instance, all of these points underneath of it also have x values that are pi over 2. And therefore the top of this fraction is always going to be 0 for those other 4 points. And it doesn't really matter what's on the bottom because anytime you have a fraction with 0 on the top, the answer is 0. So all 4 of these points are also going to have a 0 slope. So sometimes you can use shortcuts like that. Here's another one. Over here, let's go ahead and do these ones. Here, we're going to end up with, let's say, a slope. We're going to plug in 0 for x. And then we're going to plug in for y. Now, cosine of 0 is 1. And 4 times 2 is 8. Now, that's a really small slope. In other words, it's a pretty flat line. So it's going to look almost flat, but not quite flat. It's a little bit hard to do on my screen. It should probably honestly be a little bit flatter than that. Now, if you do the next one, cosine is still going to be 0. I do this one here. Cosine is still going to be 0, so I'm still going to get 1 in the numerator. The denominator, though, is going to change. It's going to be 4 times 1. And that's still pretty flat, but it should be a little less flat than this one. It's hard to tell. All right, then the next one, we're going to plug in 0. Now, this is where things get interesting. I'm going to plug in, for this point, we're plugging in 0 for x, and we're also plugging in 0 for y. Now, when you plug in 0 for y on the bottom, you're going to get 0 in the denominator. And when you have 0 in the denominator, you have an undefined slope. You're not allowed to have 0 in the denominator. So for this point here, we're going to end up with a vertical slope. It's going to be straight up and down. Now, these other points here to the right are all going to be the same. Now, we run into a little bit of a problem here because remember how I told you earlier it was going to be a horizontal? Well, actually, it's not. Now I have to change my mind because I realized that even though cosine is pi over 2, the top is 0, the bottom is 0. And you can't have 0 on the bottom, so the undefined wins, okay? You can't have 0 on the top if the fraction doesn't even exist. So actually all 4 of those points there are vertical. And you're just going to keep doing that for all of these. Let's do another point here. Pi over 6, 2. So I'm going to plug in pi over 6 for my x value. I'm going to plug in 2 for my y value. Now cosine of pi over 6. What is that? Cosine of pi over 6. Cosine of pi over 6 is radical 3 over 2. Bottom is 8. Okay. So now if I multiply the top and the bottom by 2 to simplify this fraction a little bit, we end up with radical 3 over 16. Now radical 3, that's a really weird slope to have, right? How do we graph that? Well, here's the good news. Radical 3 is basically just 1 point something. Doesn't really matter what it is. And the bottom is 16. This is such a small slope that who really cares? It's basically just going to look flat. I mean, it's going to be very flat. It's not quite 0, but it's very small. We're just estimating it, okay? And then you're just going to keep doing that for every point, okay? Now, I'm not going to do every one of them on the video here, but that's basically the idea, is just to kind of go through and keep finding the slopes at each point. As it turns out, most of these slopes are just going to end up being really, really flat. So it's almost just going to look like straight lines all the way across, except here at the x-axis, you're just going to have a bunch of vertical lines. Honestly, that's probably just not the best slope field to try sketching. I probably should have picked just a different one where the differences could have come out a little bit more so, but hey, maybe we'll get the opportunity to do that in example 2b. Anyway, so there is number 1. Let's go ahead and do the last one, number 2. Now, number 2 is actually a review question. It's not something that we learned in Unit 2. It's something we actually learned about in Unit 1. So what it's asking us to do is it's asking us to find the equation of the tangent line at x equals 0. Okay, so if you want to find the equation of a tangent line, you need 3 things. You need an x, you need a y, you need a slope. And then once you have those things, you're going to use the formula that I gave you guys at that time. Looks like this. Okay, and we're going to plug the x value that we have in for x1. We're going to plug the y value that they give us in for y1, and we're going to put the slope in where it says m. Okay, now they gave us the x value at 0, and you might be wondering, well, how do I find the y value? Well, they tell you it right here. The y value, when you plug in 0 for x, is 2. Okay, and then we're going to find the slope. So how do we do that? Well, you take the derivative, which they've already given us, and you plug in the x value that you're working with and the y value you're working with. So cosine of 0 is 1, and 4 times 2 is 8, so I have a slope of 1/8. And therefore, my final answer is going to be 1/8 x minus 0 plus 2. And that's good enough. If you want to simplify it, you can, but you don't really need to. Okay? So there's that. And that takes care of FRQ 2A. All right, let's go ahead and take a look at FRQ 2B. And after that, we'll be all done. All right, so which one would we start with? Once again, you want to start with the particular solution one because that one's worth the most points. So I'm going to start there. If f of 3 equals 1, find the particular solution. All right. So first thing we do is, and once again, hopefully you guys have tried this one on your own before you started watching this video. It's kind of important. So the first thing you want to do is start getting the variables on the same side. Isolate the variables. So I'm going to multiply both sides by dx, and then I'm going to divide both sides by y. Now you can divide both sides by 2y if you want to, but I'm just going to divide both sides by y. Now if I do that, I have this. So if I multiply both sides by dx, I have 2x squared dx on the right. And if I divide both sides by y, I will have dy over y. Now I don't personally like to write this in that way. I just did that because it makes sense initially, but ultimately I prefer to write it like this. One over y dy. Okay? So instead of having dy over y, I prefer to write it as 1 over y dy. The next thing we're going to do is we're going to integrate. Now, in this case, if you guys had a 2y down here, to simplify this problem, you're going to have to do some u substitution. If you left your 2 over here, you can avoid that. That's why I did it. But you will still end up with the same answer no matter what, so it doesn't matter. But I went the way that makes the process a little bit easier. So the integral of 1 over y is ln of y, and you don't want to forget your absolute value bars. That's kind of important. And on the right side, if we integrate that, I'm going to add 1 to the power and divide by that number. And we would get this. So separating the variables is 1 point. Integrating both sides correctly is 1 point each. So now we're up to 3 points. All right. Now we want to find our initial condition. And this is the step where you're going to plug in the values that they give you. So I'm going to plug in 1 for y. And I'm going to plug in 3 for x. So I can solve for c. Now ln of 1 is 0. In this case, we have 3 cubed, which is 27. 27 divided by 3 is 9. And 9 times 2 is 18. So this whole thing simplifies out to be 18. And then we're going to subtract on both sides, and we end up with c equals negative 18. And that's your fourth point, being able to plug in your initial condition and find your c value, negative 18. That's another point. All right, so now we're going to come back to our general solution, which is the one with the c in it. And I'm going to replace the c with what I just got for c. And what we got for c was negative 18. Okay? Now what I'm going to do is I'm going to get the y by itself. So the way you do that... Mr. Bateman? All right. So, sorry, I got interrupted there a little bit. That's okay. I'm a teacher. Back. Okay, so the way you get y by itself is you exponentiate both sides. And what that means is you make both sides a power of e. That's what cancels out the ln, which I haven't done yet, but I will. But you just make both sides a power of e. I'm going to go ahead and say that those cancel now. And then we have y equals e to the 2/3 x cubed minus 18. Now this is totally fine, this answer right here. And we'll just leave it. Now you notice I got rid of the absolute value bars. The reason I got rid of those is because when you exponentiate, exponential functions are always positive anyway. The only way an exponential function is ever going to be negative is if there's a negative multiplying the front of it, and we don't have that here. So since we don't have a negative in front of my exponential, this is automatically positive. So there would be no point in having absolute value here because it's going to come out positive on the right side anyway. Okay? So we don't need to at that point. I would say just to be safe, just so they can't ding you for a technicality, make sure you include the absolute value bars here. But at the end, since it equals an exponential, we don't really need it. Now, this is good enough, and this is where I'd like you guys to stop on your FRQ. You will get full credit for that, okay? But I just want to review you guys the something I talked about when it comes to dealing with multiple choice questions. In multiple choice questions, for some reason, mathematicians prefer to do this. Instead of leaving it as minus 18, they rewrite it as a separate term. So instead of just putting minus 18 in the power with the 2/3 x cubed, they rewrite it as e to the negative 18. Okay, and we talked about that in our lesson, so hopefully that's not a total surprise to you. And so two ways that the answer could be written is that they might write it like this on a multiple choice test. Or since that's the negative power, they might even write it like this. Now, don't do that on your FRQ. There's no reason for that. I'm just showing you guys stuff to keep in mind for multiple choice type questions. What I boxed down here is a good answer. Anyway, so there's that. Let's go ahead and move on to the next one. As I said, number 4 is pretty quick and easy. We want to sketch the particular solution at 0, 2. So I'm going to put a point at 0, 2. And if I were to try to sketch the particular solution at that point, following those curves there, we would end up with something that looks like this. And that's another pretty quick and easy one-pointer. So right there, you've got 6 points, and you would have passed the FRQ on the AP exam just by doing those two alone. So you guys could see why I'm saying don't worry about the slope fields until the end. That's if you have time, because you do all this work, and they're only worth 1 point. Number 2, we'll do that also. That one's pretty, they're not too bad once you guys know how to do number 2. So I mean, that's some nice opportunity to get some points as well. But let's go ahead and take a look at number 1 first now. So same thing as last time. You're just gonna get the coordinates of the point. You're gonna plug it in. So the coordinates for this point are 1, 1. And if I plug that into my differential equation for x and y, I'm plugging in 1 for y. I'm also plugging in 1 for x. Well, when you simplify that, you just get 2. So I end up with a slope of 2. Now, a slope of 2 is going to be, maybe something like that. So long as it's positive, you're good. Let's go ahead and do the next one here. Now, in this case, the x equals 0 and the y is 1. Now, if you plug in 1 for x and 0 for y, you're just going to get 0. And so for every point on this axis, you're just going to have a flat slope, because anytime you plug in a 0, you get 0. The only exception would be is if you have an undefined. Sometimes if you plug 0 in the denominator, you can get 0 there in the bottom, and that makes it undefined, which we saw in the last one. But in this case, we don't have a denominator, so nothing's going to be undefined. If you plug in any point on the axes, you're plugging in a 0 for either x or y, and therefore all of those are going to come out to be 0 slopes. Right? Now, as for this one over here, negative, this one on this side, let's plug that one in real quick and see what that comes out to be. So plugging in 1 for y and negative 1 for x. Well, in that case, when I'm squaring a negative 1, I'm going to get the same thing as a positive 1. So this slope over here is going to look identical to the one I had on the right side, and that's because we squared the x. So the negative of the x didn't even matter, so we ended up with the same exact slope. Same thing's going to happen down here, actually, as well. Let's go ahead and do that. So in this one, we're going to plug in, you're going to get a different slope, but what I mean by the same thing's going to happen is this side is going to look the same as this side, but it won't look the same as the top because we do have a negative y value. So for this point here, it's negative 1, negative 1. So if you were to plug in negative 1 for y and negative 1 for x, you're going to end up with negative 2 as a final answer. So it's going to look like the one on the top, but going in the opposite direction, in a downward direction. And this one's going to look the same because you're going to plug in the same y value. The only difference is you're going to plug in a positive one, but when you square it, you're still going to get the same answer anyway. So that's what that slope field would look like. All right, let's go ahead and take a look at number 2. Find the equation of the line that is tangent to the graph of f of x at x equals 3. And as we said before, that means we need an x, we need a y, and then we need a slope. Now the x they give us is 3. And from up here, we can see that when x equals 3, y equals 1. And so to find our slope, all we have to do is plug in the x value and the y value that they gave us. Slope into our differential equation there. So I'm going to plug in 3 for the x, and I'm going to plug in 1 for the y. That's going to be 2 times 9, which is 18. And therefore, the slope, or the equation of the tangent line is going to be 18 times x minus 3 plus 1. No need to simplify. We're ready to go. So once again, when you're doing number 1, you get 1 point for the entire slope field. When you're doing number 2, sometimes they break this up into 2 points, and that's what I'll do. They'll give you 1 point for accurately finding the slope. They'll give you 1 point for accurately writing out the equation of the tangent line. Okay, and so that's that. That's your FRQ. You'll have questions like these next Wednesday. You'll have 35 minutes, so you do want to make sure that you're, budgeting your time well. That's it. All right, guys. That being said, I think we'll call it a day on this, and we'll see you guys later.